Hello everyone, my name is Özlem and I'm presenting my project titled EEG Anomaly Detection using a MATLAB-based graphical interface. This project focuses on identifying irregular patterns in brain signals, particularly using EEG electroencephalography data through a simple user-friendly tool developed in MATLAB. We begin with a quick overview of what EEG is. EEG is a non-invasive technique that measures electrical activity in the brain through electrodes placed on the scalp. It's widely used in medical and research settings to monitor brain health, detect neurological disorders like epilepsy, and study deep cycles or cognitive states. The challenge, however, is that interpreting EEG data usually requires expertise in signal processing and often complex software. The motivation behind this project was to bridge that gap by creating a lightweight, interactive MATLAB-based tool that allows even non-expert users, such as students or educators, to visually detect anomalies in EEG signals. Those anomalies often represent important physiological events like seizures or signal artifacts. The main objective of the project were to build the application using only basic MATLAB tools, no additional toolboxes, to ensure the tool can analyze real EEG data, to allow user interaction through adjustable parameters like threshold sensitivity, and to validate the tool using both simulated and real-world EEG datasets. Now let's talk about methodology. The process begins by loading EEG data in TXT formats through a file picker in the GUI. Once loaded, the signal's first derivative is computed using MATLAB's diff function, capturing the rates of change in the signal. The standard deviation of this derivative is then calculated. The user enters a threshold multiplier, say 3 here, which is used to create a dynamic threshold. Any point where the derivative exceeds this threshold is marked as an anomaly. And the red circles indicate that. The GUI itself includes several components. Buttons for loading data and detecting anomalies, and editable field for threshold inputs, and a plot area that displays the signal in blue with anomalies highlighted in red. The GUI is built using standard UI figure, UI button, UI access commands. Here you can see the pseudocode that is used in the script from start to end. And also you can see the MATLAB functions used in this graphical interface, graphical user interface function. We talked about this. Derivative shows rate of signal change, and anomalies points where change exceeds typical variation, highlighted in red, as we said. We then demonstrate the tool's output visually in two scenarios. Like in the first, we use a synthetic EEG-like sinusoidal signal with noise. Here, only a few sharp dips are flagged, demonstrating the algorithm's restraint and precision. In the second, we load real EEG data from CHP, MIT, epilepsy dataset. This data includes dense, high-amplitude bursts, and our tool effectively highlights these as likely epileptic events. Performance-wise, MATLAB's profiler indicates that the tool processes signals in under 1 second, even for long data sequences. And this indicates high computational efficiency. In terms of benefits, the system is lightweight, easy to use, and doesn't rely on specialized toolboxes. It's especially useful in educational environments or introductory research contexts. Uh, However, there are some limitations. Currently, the system supports only single-channel TXT files. It doesn't yet support EDF files or multi-channel visualization. So looking ahead, future versions could support more data formats, offer exportable results, or allow side-by-side channel comparisons. To conclude, this project shows that even simple signal processing techniques, when integrated with a user-focused design, can make EEG analysis accessible and informative. Thank you for listening. I'm open to questions.